the water comes from upstream from the creek, getting into this sedimentation pond to make sure the particles settle first, and then going to the main part of the wetland. So you can see the wetland as Dale described the day before yesterday. The wetland is going through a S shape to make sure the root is longer, as long as possible. So it's getting a longer period for treatment. So this is the inlet of Troups Creek wetland. This is a good site because we have done a few years research for this wetland. And you can see different things about the wetland itself, and the sedimentation pond, the structure of the wetland, and also sensor technologies. And because of the long period of the dry weather, some part of the wetland has already dried. So you can see the soil in the wetland. So let's go to the inlet first. I can show you some sensors and also the rubbish trap. Okay, let's get in. This is the Troups Creek. So the creek comes down and we do some modifications and structures to make sure there is a big trap here to trap a lot of rubbish. So the big particles like the rocks cannot get into the wetland. So this part we did a lot of research, but due to long period of the dry time, like we cannot see a big flow from the creek because people are using the water upstream from the creek. And here we have a lot of sensors. So you can see, as I described yesterday, there is a cabinet. I can open it later. It stores different kinds of auto sampler and the data logger. And also you can see here, when we install the sensor,
we can walk down through the step there. Yeah.
And put the cable underneath. So you can see this is a flow meter. And there is another turbidity sensor in this pot. So previously we have a lot of sensors here. Anyone here? Just wait a little bit. So normally the water will reach this area, and the normal water level is about 20 centimeters deep. And when there is a big rainfall or even small rainfall, it will rise up a lot. Sometimes I can see the full channel is full. And we do have sensors here. The sensors connecting to the data loggers in the cabinet. And we need to dig a big trench to make sure the sensor cable is underground. And this is a flow meter. So we put it in the middle. When there is a rainfall event, we know how much flow, it can detect how much flow getting into the wetland. And here, there is another turbidity sensor, which is like this big, similar as a pipe, and we just hide it inside and make sure the long cable connect to the data logger inside. So previously we measure the different parameters like the turbidity, the flow, and we do a lot of modeling stuff to understand. We take the samples from the inlet and also the outlet, so we know the pollutant level and we do the modeling. And then we developed some sensors, so it's easy for installation, so we don't need that big cabinet. We just put our sensor logger box and our sensor here. It's easy. We use about 20 minutes to install this sensor. But that one, we need to dig trench, we need to do a concrete base, and we need to put a cabinet on that. It's 3 days, full day time to install these kind of sensors. And we install different kind of sensors. This is a radar sensor to measure the water depth. And we also have some turbidity sensors. You can see there are 2 poles here. So previously, we just make our turbidity sensors attach on the wall. So it's easy for us to do the maintenance and to do the monitoring. And also, previously, let's come in here. So previously, we want to understand the rubbish level in this area. So we put we have already done that, but we put a camera here. So the camera can upload the pictures on the website, so we can see how much rubbish inside. so we can reminder the authorities to clean the rubbish. So this part trapped some rubbish, and the water can flow in downstream to the sedimentation pond. Yeah. So let's get up and we can open the cabinet for you. Yeah. So previously in this cabinet, we do have different kinds of sensors and data logger. So this one is a data logger for the flow meter, which is very big. And this one is a data logger for another turbidity sensor we saw inside. And this is an auto sampler. It's super big and it had a different, I think. Yeah. So we can put bottles. We can put the bottles inside. So we take the water sample and it pumps the water from the inlet. So we fill in different bottles, at most 24 bottles, and then we take the water sample. So this kind of thing, it's not that, it's too big. And we need to use 2 big batteries to power all of this device. And after each, maybe, it depends on how often we use that. Sometimes each month we need to change the batteries, very heavy. And then after that we found it's not very practical and it's hard for installation. So we design our own sensors. For example, we use this small one, and we just make all the things in a small logger box and power by using this small battery. And by using this, we can real-time understand the pollutant level inside, and we can use that to control all the devices. Previously, if we want to take the water sample, and for example, we know there is a rainfall event tomorrow, and we need to come today and set up all the programs on this machine, and then we close the door, and finger crossed there is a rainfall event on time, because the weather forecast in Melbourne sometimes is really bad. And now we don't need to worry about that. So we use the purple board inside, connecting all the devices, and we can sitting in the office and just change some settings online, and then it will receive signal from the website, and then we can start and stop doing the sampling. So that is real-time control and real-time monitoring for this wetland. And also at the sedimentation pond, now you can see there is a big pond here. It's very deep. So as Dale said, the sedimentation pond sometimes should give enough depth to make sure the particles can settle down to the bottom. So that one is very deep. We need to go to the outlet there later. And you can see some people, I'm not sure if he's fishing or not. No. And you can see there is a small green cabinet at that time, at that area, because there is a penstock. So there is a wear and there is an automatic penstock. So we do real-time control by using these IoT devices, so we can lift it up and put it down. Just open or close the penstock to make sure we can control the water level there. So I can show you later, so we can walk there and show you later. Yeah? Yeah. So this is a sedimentation pond, and you can see the water level is not that high. And sometimes if you're getting closer, it can reach up to maybe about 30 or 40 centimeters higher. And there is a big pipe under the ground, so the water can go through this way, getting into the main part of the wetland. So when we designed this wetland, or the Melbourne Water designed wetland, they put a penstock here. So you can see here's the actuator. And they want to previously, they want to manually open the penstock when the water level is very high, and when the water level is lower, they want to close the penstock manually. But so in the past few years, we found that we need to use some more innovative technologies to make it smarter. So we use a real-time control technology. So this is the actuator. So we can use all of these machines inside to control it remotely by ourselves. So if the water level is high, or we use some sensors. Actually, we have some sensors. If you can't see that, if you come closer, you can see there is a PVC pipe on the side. So it do have some sensor attached on the PVC pipe, like the water level sensor. So we know the water level And then if the water level reaches a certain point, we just automatically use this machine to open the penstock to make sure the water can drainage to the downstream. So this is what we are doing here. And after it getting into the downstream, the water start to have the water has pre-treated here, the particles have been settled, and the water has started to treat in the wetland. So after maybe, I think the design period is 72 hours. So the 72 hours time, the water pollutant level will be lower than the inlet. So some colleagues asked me some questions. The first thing is what kind of the water quality, like the pollutant level in this wetland. The reason I show you this wetland is it's a per design wetland. It's not that good because the performance sometimes is not under our expectation. We make the wetland, we design the wetland to make sure the water quality can be improved. But sometimes for certain parameters, like the pathogen level, like the turbidity level, at the outlet of the wetland is even higher than the inlet because there are some problem inside. I can go through the wetland with you to show you which part is a problem. I can tell you the first problem is a macrophyte zone. There is not enough plants in the wetland because the plants has a function to trap or absorb these kind of particles. But because of the die-off or because of the design problem or because of the budget problem, they don't have enough plants inside. You can see there is a very small amount of area has a plant. When you go through this wetland, you can have a look. And the second thing is lack of maintenance because the maintenance is so less frequent. So there are a lot of clay underneath. And some part is very shallow. It's supposed to have some plants, but it doesn't have. So when the wind, for example, you can feel the wind, or some waterfalls, the ducks or the birds, they are playing in the wetland, they make a lot of resuspensions. And the clay particle is so small, it's very hard to settle in the small, like in the shallow area, which makes the water, like turbidity level at the outlet very poor. And if there are more particles inside, that means a lot of pollutants, for example, pathogens, can attach on the particles and make the turbidity, make the pollutant level higher than what we think. And also there is another problem. It's a lot of birds around. I think it's too dry. You can't see too much bird, but normally there are a lot of birds, and they have the fecal like deposit. They poop on in the water. So
it's a good problem to have.
Yeah. They can feed the fish, but the pathogen level will be super high. For certain pathogens like the E. coli or Campylobacter is super high at the downstream. So a few problems you can see, and also when you go through the wetland, go along beside the wetland, you can see a few places has been dried out. You can see the soil underneath. So yes, this is the outlet, and also at the outlet of the wetland, you can see a harvesting pond, and you can see a storm of harvesting tanks. So you can have a look. Yeah.
The only thing I want to say is that thinking about what Mel just said about the resuspension in the sedimentation basin, because we're going to address this problem in the Qinghai project, in the design, right? We won't share with you some of the solutions. We ask you to think about yourself first. How do we address the issues in the design?
Yeah. Okay. One thing I forgot to mention is the overflow bypass. So there is a bypass from here to here. You can see this bridge. So if the flow is very high, I'd better stand on the ground. If the flow is very high, the more flow, the overflow will go through this bypass. You can see there is a lower ground, so bypass to the outlet. So you can see that. So when you design that, we need to think about it either underground or on the surface of the ground. So make it lower and elevation lower to make sure the water can drainage downstream. Yeah. Yeah.
Are these how going to be affected by the flood?
Is powered by 240 volts. So we have a regulator here. So these batteries are only, I think, 26 volts. So we need to regulate up the voltage to power this one.
How the frequency that you have to bring these to recharge?
Well, it depends on how much time, how many times you level up or down. Yeah.
You mean you need to control?
Yes.
How many times that?
Yes. So because now we are doing research, it's not a real operation for this real-time control, but the research we are doing is to see how much like the turbidity, how much the pollutant level has been changed by real-time control to compare with without real-time control. So currently we don't have to change the battery too frequent, but in the future if we want to do the real operation of the real-time control, we probably do not need to use these batteries. We just use a power line to power all of these devices.
I'm wondering, do you consider using solar energy?
Yes, we use solar energy, but I don't know why they didn't.
I didn't see any panels.
No. Previously, I think they dismantled that. Maybe some problem with the solar energy, but I mean the device, not the solar energy. Previously, we have a big solar panel. We have just a big pole and make sure there's nothing hide on the solar panel. But sometimes, in Melbourne, it's really rare to see so long period of the sunny weather. So
the weather is kind of
especially in the winter time, there's no solar at all. So sometimes it doesn't work. So for example, the small like the logger box like this. So we do use 3D printer to print a frame and put a small solar panel on the top. So we use that solar panel in Laos and in Vietnam, so they can receive the solar to recharge the battery. Yes.
This is a sediment pond, okay? If this is inflow, okay, and this is outflow going into the wetland, and normally on the side we have a overflow weir, which is the bypass. Okay, so this is the bridge where we're standing above. That's a high flow bypass. So when the pond is full, the water is forced to go this way, so it is not scouring the wetland. So high velocity always going through this bypass. That's what you see here. Right? It's overland flow pass, and this is the inflow. And that one you can set as like a set level, but this one preferably we can design with a actuator that you can change the water level based on seasonality. So that is very important. In every wetland we show you this week, always have a high flow bypass weir.
So where's the bypass connect to?
Connected downstream.
Oh,
Yeah.
downstream.
So depend on objective, right? That's a good question, right? If you look at, if this is the pond, this is the wetland. Okay. So if the primary objective of this wetland is to let's say flood attenuation, then the bypass will connect to this outlet, the final outlet. This is where they combine. Okay, the downstream. But if the wetland is about maximizing how much water we harvest, then it connects back to here. It connects to just before the outlet.
It depends on the function.
Depend on the function. Okay, because we also want to make sure the bypass is also connected, right? So it depends on the objective how you want to design it. So that's a great question, right? That's one option. That's another option. You will see this wetland is connected here, because we're trying to maximize the water we can harvest, but at the same time protect the plant here. So it bypasses the plant, but still finish up at the final polishing pond of the wetland.
It's just for high flow bypass.
But in the rainy time, the quality is not same.
Yeah.
Because this is already like
Yes.
a treat.
Yeah.
But when the rainy come,
Yeah.
more maximum flood it come here
Yeah.
and mix that the
Mix
water
that,
that
yeah.
you already treat.
Yeah.
The quality is go bad again.
Yeah. So which means that the trade-off is that the further treatment cost is increased in trading off for the quantity. Right. It only works if the water price is high. If the water price is low, then no point. You only take the water that has been cleaned. But when the water price is so high in Melbourne, it still works well to capture that bit. Good.
Here, you can see a lot of plants in the middle.
Good place.
Yeah, good place. I'm waiting here. So there are a few plants in the middle of the wetland. They are manually planting there. So this is we call the macrophyte zone. So
Anyone want to get up there?
the macrophyte zone normally in the big wetland, such a big wetland, we do have at least 50% of
Doing
the.
election campaign.
and about 50% of the wetland area should have the plants. So you can double check the design guidelines. So for different area or different states, we have the different standard. So, but in this wetland, we can see this is the only one of a few area has the plants. Some of the plants they replanted has been died off. So it doesn't get into the function to absorb or to mitigate the resuspension of the particles. So you can still even see there are a lot of clay underneath because they didn't do, and the rocks, yes, underneath the rocks there are a lot of clay, so make a lot of resuspension in the turbulent flow. So the turbidity is very high. So if we plant more plants in the wetland and make sure the water is deeper, so that means we can make the water quality treatment even better. So this is a pin part of this wetland. So after you go through this way, you can still see a few parts they supposed to have plants, but all the plants died off. So after we go this way, you can have a look. So
This rock is one of the function of you decide that
I think
or natural.
I think they are nature rocks, but they didn't do the maintenance because a lot of I have done about half a year of the sampling monitoring here. So I just put the turbidity sensor there because between the rocks, they're supposed to remove that. Between the rocks, there are a lot of clay, and the rocks cause the turbulent flow to make a lot of resuspension. So this area is almost the highest turbidity part in this wetland because a lot of resuspension here.
I think you put the rock for retard the water, something like that.
Yeah. So the
Before the wetland, this is a creek.
Yeah,
This is Troups Creek.
yeah.
Right?
yeah. So the wetland is just along the Troups Creek. They getting into the wetland and do a stormwater treatment and harvesting, and then discharge to the downstream.
Okay.
And this wetland, as I said, the reason I come here to show you this wetland is because we have every research technologies, all the research technologies here. And also another thing is this wetland is not a good, perfect example to show you.
Okay.
I will show you which part is not good. So
Okay.
in the future, when you design that, you
Okay.
will avoid that.
Okay.
Yeah.
Good.
Yeah. Let's keep going.
Because we're trying to design a S meandering shape, right? The berms are where we can put the island there for birds. Then you can plant trees, bird habitat trees.
นี่เขาเคลมเลยเขาเคลมเลยว่าเนี่ยคือเป็นแล้วก็เขาบอกว่าอีกอันนึงคือประโยชน์ที่เขาบอกว่าเนี่ยคนรอบๆเนี่ยมันก็จะได้พาร์คเป็น
Okay.
He's going to cast a vote.
Yeah. So here we can see this is the deepest area of the wetland. So we can still see some water inside, but some part of the wetland it's almost exactly, completely dry. And this is the lowest water level I have ever seen in this wetland because previously when I came here doing my research or doing monitoring, I can't see any land and any soil in the middle of I can't get into the island, but now I can walk into the island without making my shoes wet. So this is the lowest water level. And also you can see there is a pole standing in the wetland. So that is why I keep emphasize this, because I can give you ideas by using some innovative sensors. So you can do the monitoring of the water body wherever you want. You can just make a pole standing in the wetland and then you know different kind of information. You know the water level, you know the electrical conductivity, which is related to the salinity of the water, and also turbidity level, which can be correlated with pathogens and correlated with TSS and correlated with nutrient. So this kind of monitoring, you can do it in Thailand as well. And also, we can see there are two tanks. One is hid by the tree. There is the rainwater tanks, or the stormwater harvesting tanks. So after the wetland water has been treated, and they pump into this stormwater tank. So this stormwater tank can the water in the stormwater tank can use for I think if I'm correct, it's 23 households downstream. So they use that for water irrigation, I think definitely not this period because it's too dry. There's no water inside. But previously, during the winter time or the wet time, they use the water for toilet flushing and for the irrigation. So we can before we get into the bath, you can go through this way, and you can see there is a big shipping container there with all of this like UV, LED, all of the treatment devices inside. So you can see the water can be well treated to make sure if people touch that, there is no health problem. Yeah. So in this wetland, we do have the the real-time control and real-time monitoring. We do have the water treatment, and we do have the water harvesting facilities, and we can use it for water reuse. Yes.
So,
Yeah.
how do you supply water to the water treatment plant that you mentioned earlier?
Water treatment plant.
Yeah.
You mean this one?
Also, so it is a treatment plant.
Not treatment plant. They just have very simple and very quick water treatment devices. So after the water treatment, you can see it later when we get there. So there is a treatment harvesting pond, and the water is treated. And the treated water is directly getting into that after extra treatment, like the UV, LED, or like the filtration, infiltration, or this kind of thing. And then getting into the water tank, remote tank. And the remote tank, the water can be reused.
So the water gets treated
Yeah.
downstream.
Yes, and then pumped into here. So there are different levels of treatment. One is NBS, one is we call it passive treatment because it's we didn't do anything, and then it's active treatment. So we use some devices to treat it. Yeah.
I just want to explain to everyone. Thanks, Mel. Because Dr. Wall just looking at this, right? You probably look at this as well. One of the design things everybody think about is we start at this point, right? This is a creek, right? Sediment basin and wetlands going this way, right? And one of you guys asking this bypass, high flow bypass, it finishing up here, right? This is where we take for stormwater harvesting. And when you have another catchment coming here, you don't have to route all the way to this beginning. What you do, you build another wetland. This is exactly what's happening here. This is another wetland looking after another catchment. And then after you treat it, you merge this outlet to this wetland. See the outlets here? Right? Don't try to take this water, go through this again. It's a long way, long road. But build another small wetland that is proportional to this catchment. Treat that water and then merge that with this wetland.
Okay. So that's how you improve
Yeah.
the capacity of the wetland, right?
Yeah. But also this, because the whole thing is retarding basin, everything draining to here, whether you like or not. So we have to deal with that. The starting point of the creek downstream. So everything goes back to this creek, overflow, everything goes here, and then become a creek again. Yeah.